Section 7.5 doesn't have anything new in it. It just has a summary of the stuff that we've tried so far, the stuff that we've learned so far about integration. Um, Sort of gives you an outline of the things to look for when you're trying to solve integrals. Um, and maybe it gives a little bit of extra stuff, but not really. What I see 7.5 is a wonderful source of practice problems. If you take a look at the problems at the end of section 7.5, there's just a ton of integrals to try. And you don't know what section they came from, so you don't necessarily know what technique to try. So it's really good practice. You get, of course, the answers to all the odds in the back of the book. But here's a general outline that they go through. First thing, simplify or otherwise rewrite. You got some integral. I mean, that's essentially what all of these are, is you're rewriting them. We're trying to write them in a way that we can recognize. Sometimes, though, it's just a matter of algebra. Sometimes just distributing something out, turning a product into a quotient. Sorry, turning a product into a summation that way by the distributive property. Sometimes you might want to actually take a couple of fractions and add them together into a single fraction to see something, just make it look different without changing the value. Then the general technique that I think is the first one to look at is try U substitution. Look for something that you might be able to simplify by U substitution. That doesn't work, then you go into, okay, what kind of stuff does it look like? Does it look like maybe a product of a couple unrelated things? So maybe integration by parts might be useful. Is it just a rational function, right? This rational function thing really falls, I think, in this simplify or otherwise rewrite. I mean, you're just doing algebra to do this partial fraction stuff. There's no calculus really involved. You're rewriting one big fraction as the sum of a bunch of smaller fractions, where the smaller fractions are actually things that you can integrate. So that kind of falls in this category, but it was a specific technique we looked at. Trig substitutions. Do you have things that look like x squared plus a squared, or x squared minus a squared, or a squared minus x squared? Is it something that looks like a trig substitution might work? And in the event that none of that stuff works, well, then there's number 4, which is to try something else. Maybe keep in mind that you can always do integration by parts, because you can always let u equal the whole thing, and then dv is just the dx. And that allows you to take the derivative of the thing that you're trying to integrate rather than integrating it, and then be left with another integral that hopefully can work. Anyway, there's a lot of different things. One of the things I want to do is I want to give you one example of essentially a non-standard U substitution. One of the things that the book does say in this section 7.5 is that there's really only 2 techniques. There's integration by parts and there's substitution. Essentially, they're saying that U substitutions and trig substitutions are really the same thing. I see them differently in that U substitutions generally make your integral look more simple, and your trig substitutions generally make them look more complicated. But really they are the same thing. It's just a matter of which variable are you focusing on. Let me do an example here. So I want to look at an integral of e to the square root of x dx. Not an immediate U substitution. I mean, I think of that radical x in the numerator, and I think, oh, u equals the square root of x. But then I'd need its derivative somewhere, and I don't see the derivative of the square root of x anywhere. Right? Well, actually, it turns out this is the substitution I want to do. And I want to look at it 2 ways. We would think of a U substitution generally as u equals some function of x, and then du, you would calculate the derivative times dx. So this would be 1 over 2 times the square root of x dx. I want to think of this as well in terms of how we do trig substitutions. So rather than saying let u be the square root of x, what if I said let x be u squared? I mean, the relationship is the same here. But when I think about plugging it in, I would be plugging in for x something bigger, right? And likewise, then dx is 2u du, and substituting in for the dx would be something bigger. That is, I take that integral and rewrite it as e to the square root of u squared times dx, which is 2 times u du. Now this is a u substitution, it's this u substitution, but it's done in a way that looks like a trig substitution, that initially everything gets more complicated, not less. But we've done this with a purpose in mind, particularly with x equal to u squared, it's going to get rid of that square root, right? This then becomes, well, there's a 2u out in front, and then you've got e to the u du. And now this actually is an integral that I recognize as probably being not trig substitution, integration by parts would work pretty well here. And since I already got a u in there, I'm going to do v and w. So I'm going to do v and dv, w and dw. I'm going to start with v and dw. So I'll start with the 2u right here, and I'll start with the e to the u du right there. So this is 2 du, and integrate this to get e to the u. So it looks to me like this integral is this times that, so 2u e to the u minus the integral this times this, 2 e to the u du, which 2u e to the u minus 2 e to the u plus a constant, and then I say, oh, but I know what u is. What was my substitution? U is the square root of x right back up here, right? So substituting back in, I've got 2 times the square root of x times e to the square root of x minus 2e to the square root of x plus a constant. Okay. So yeah, that was a u substitution, but I think it was easier to visualize, see what we were doing by thinking it this way, like we might do a trig substitution. Okay. Anyway, there's a lot of different things that you can do like that. Try something. Don't break any rules. Do algebra correctly. When you need a du or something, when you're taking a derivative, do those derivatives correctly. You can substitute in and out different variables. You can do integration by parts. Sometimes it takes a few steps. You might have to do one technique and then follow by another. And essentially, that's what I did here. I did a substitution, and then I followed it up with integration by parts through here. Anyway, 7.5, a lot of practice on all your integration techniques.